periodicity in elements.
Okay, so means the chapter 3rd you are supposed to study, yes?
Yes.
Okay, great. So if you talk about chapter number 3rd, so periodic classification, right?
Yes, sir.
Classification and periodicity in properties. So, okay. So first of all, the things we have to understand, that is what is the need to do that? Need of classification. Okay.
Yes.
That you need to tell first and then I will tell. Okay. What can be? Why we are supposed to classify the element? You are not visible to me. You are not visible. Your camera is off.
Yes, sir. Sir, the reason to classify elements, sir, might be that like grade them on the basis of certain properties, so that if we find one element, then we can guess the properties of the other ones which are in the same classification group.
Yeah, absolutely correct one. So first one, like suppose, like so, if you can give the examples, right? What example we can give? Like you are having the.
Like for example, we can use a noble gases. That one noble gas is similar to the other ones in property.
So that to save the time, first things we can save the time also. No, to save time. This is also very useful to save the time, because what you are going to do, because you need not to study all the element general properties. Simply by studying the group properties, group character, you can be able to understand the properties of other element. And secondly, to make the study easy, okay, to make study easy. So these things you are knowing. There are model of classification. Can you tell me what are the model of classification?
No, sir.
Okay, so there are many models are there. The first one, if you talk about Dobereiner,
Achha, sir,
D-O-B-E-R.
that I can tell, sir. Dobereiner Triad, Newland octave, Mendeleev periodic table, and the modern periodic table by Henry Moser.
Okay, Dobereiner Triads is there. Second one is there, Lowther Meyer curve. Lowther, M-A.
Lowther Meyer's atomic volume curve.
Curve. And second one is the Mendeleev one. No, Newland. Here is the Newland. Newland octave is there. And you already told that is Mendeleev.
Yes, sir.
Mendeleev. And lastly, it is there. What is then modern periodic table? So you already told me that is first one. Tell me the first one.
Sir, Dobereiner was scientist to arrange them in the orders of three elements each, and those three had the same properties, similar properties.
On what basis he arranged the element in the group of three?
Sir, on the basis of atomic weight and chemical property.
On the basis of atomic weight. How? Tell me the law.
Sir, law I don't remember.
Law is, he said, if you go in detail, law said that is average mass of first and last element. Have you heard about that?
No.
Triads law. No, this is. He said average mass of first and third element must be equal to mass of which element? Mass of second element. This was his model. For example, if you see, he given the lithium, sodium, and potassium. This was the first triad. First triads. So you got to know that is, if you are adding, the mass of lithium is 7, mass of sodium is 23, and mass of potassium is 39. So he said that is, you add the mass of first and last element, and the average you have to calculate by 2. So it should always come, that is mass of second element. So here you see 7 plus 39 divided by 2 is equal to 23. It should come. So this is coming 46 by 2 is equal to 23, or it will 23 is equal to 23. So this is same is coming now. Yes, yeah, no. Average mass of first and third is coming equal to mass of second. So that is this was the law. Okay. What are the properties? What are the properties? Can you tell me? What are the properties they are having the similar? How can you say the triads is having similar properties? Yes.
Sir, I do not have a very detailed idea on this one, sir.
No. You don't have to have idea. Just you have to apply
They
the
should have similar chemical properties like this. Lithium, sodium, potassium, all are soft metals and they are very reactive.
Yeah. That is what I am asking now. So the first one, if you talk about, they all are the metal. Yes, yeah, no. They
Yes,
all
sir.
are metal. And
Yes.
secondly, if you talk about their valency, can you tell me what is the valency of these metal?
One.
They all is having valency 1. They are the very
Yes.
reactive metal. Okay. Then why this model failed? Then what could be the reason why the model get failed? Why
Sir,
the
but
model?
because this could accommodate only a certain number of elements, this rule could not define all the elements.
Okay. Because many triads he gave, that is average mass was not coming the same. Okay. That is why the
Yes.
model was failed. Okay. Like if I will go for the one more I am giving you, let us go with the another one. Suppose I am going to, that is third triads. Third triads. Third triads were there, fluorine, chlorine, and bromine. Okay. They are having the same properties. Okay, absolutely, they all are having same properties, same valency, same oxidation number, all are non-metal, all are electronegative. But here, if you see, here is mass is something 18. Okay, here is 35.5, and here is no, chlorine, bromine, iodine. Chlorine was not there. Chlorine, bromine, and iodine. Iodine is 127. 830. So here is, that is 80. This is the 80. So if you add, this is the going to be first, this is going to be third. You add and check whether the 80 is coming or what. So if he
No, sir, it
added,
will not come. Not come.
so absolutely it is not coming. But approx it is coming. Approx it is coming. Approximately it is coming. So here you see 0.5, 12. Okay. 8. No. 3, 2, 5. This is, I think, 6. 1 divided by 2, it is 80. So 81 point, I think 81 to 2 is 4.
1.25.
25. This is not equal to 80. Yes or no? This is not equal.
Yes, sir.
So sometime what the law they said, that is law was violating, but properties were, sometime properties was okay in the trial. Sometime what happened, the mass is accurately coming, but properties are not same. So that is why this model failed, and it is not going to accommodate all the elements. So you are able to understand. Now let me tell
Yes,
you, next one you go the Newland. Newland octave model.
Sir,
Then
the
which
NCERT book is required, sir, right now, or it is not required?
Newland octave model.
Sir, should I keep the NCERT book open right now? It is not.
Yes. Arey, yaar. This is what, how you are comfortable now. This is the everything, the motive is what, the understanding. Okay, motive is
Yes.
understanding. Clear concept should be required. And whatever the things we can use, that is what. Okay. So you are going to tell the Newland octave model.
So Newland octave model, that Newland arranged the elements in the order of the increasing atomic masses, and he found that elements after certain like we have the octaves in which the first and the eighth notes are similar. So that way, so the first and the eighth elements are also coming to be similar.
He said little bit, I'm correcting you. Every first element, every eighth element is similar to properties of first element. First element. Every eight, whichever it can be. Suppose he started at actually during the Newland time, noble gases was not discovered, so it was not included. So suppose lithium was there, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Then because noble gas was not discovered at that time.
Yes, sir.
So here it is going to be sodium, then it is going to be magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, then potassium and calcium. Up to calcium it is applicable. After that it is not applicable. Now, and see the point which we have to understand, anyone you can consider to be first. Suppose you are considering this is the first element. So 1, 2, 3. Here is 4. This is 5, 6, 7, and it is 8. So wherever you are considering to be 8, it is having the similar properties. Like if you are going FCl, so it is 9 and 17. You can see the valency. So it is 2, 7. It is also 2, 8, 7.
7.
Huh.
287, sir.
So valency is going to be what? Valency is going to be 1. Okay, both are the non-metal, both are the electronegative. So everything is going to be same. Anyone you can consider. So that was the quite better model as compared to the what the Daubigny said, because it was giving the applicable for the many element up to 20. That is, that comes many element. At that time, the many elements was not discovered. Suppose if I will consider to be, suppose you consider to be the one is asked in the, if the first element in the Daubigny Newland model is magnesium, then what is going to be eighth element?
MgL, SiPsCl. Sir, then this Ca will be the eighth element.
The question sometimes okay, that is correct one. One question I am giving you.
Yes.
Okay.
Yes.
They are saying in Triads model. This is the question. In Triads model, an element of atomic number 7, okay, is similar to which element, and what is formula of its two halide? What is formula of its two halide? So see how the question, something they change the question, mode of question.
Sir, actually, this element of atomic number 7 would be nitrogen. And sir, similar to halides. Sir, what is the meaning of halides?
Halide means halogen. That is formula
Compound
of
with any of the halogenic elements.
With the halogen, any of the halogen. Compound with any other halogen. So which element? Which is the other element? They are saying similar to which? They are saying in Triads model, an element atomic number 7 is similar to which element? Which? Similar to which element? And what is? Here is the what is. Here they are saying what is formula of its two halide.
Sir, atomic number 7 I can understand, sir, but how I will understand what is after that one, sir? Maybe this is the first one also.
No. Simple. See, this is the one now. 2, 3, 4, 5, 6, 7, 8th. So phosphorus is 8th. Yes or no?
Yes, sir.
So other element, so they are saying similar to which element? Similar to what? So nitrogen is similar to phosphorus. Yes or no?
Yes, sir.
Now phosphorus, you see, so no, this is phosphorus.
Sir, but you have given in the question the triad model, sir. You are doing by the octave model.
Sorry, yaar, octave model. I am extremely sorry, na. In octave model. Oh, I'm sorry, mistake. Okay, now you tell me. Octave model.
Sir, now definitely this would be P, and two halide will be PCl5, and another is PI. Sir, iodine valency?
One only. All the halogen are one only, na?
Then PI only.
No. It is PCl5 and PCl3. 2.
PCl2.
PCl3. See, phosphorus is there, na 15. So
Yes.
phosphorus 15, if you are talking about, so configuration is there 285. Okay. So one valency is what? One valency it will be, that is 5. 5 number of valence electron. Number of valence electron. Getting one valency,
Yes.
maximum valency is number of valence electron. Second, this is the first valency. And what is the second valency? How we can calculate the second valency? Second valency means 8 minus
8 minus number of layers.
number of V electron. So 8 minus 3. So that is 8 minus 5 going to be 3. So suppose phosphorus and chlorine, if you are taking, phosphorus is 3 here and here is 1. So if you are cross multiplying, it is going to be PCl3. And here you see phosphorus is 5, chlorine is 1. So what it is going to be? PCl5.
Yes.
Can you understand this?
Yes, sir.
Okay. What is the Lowther-Meyer model? Can you tell me? Lowther-Meyer model.
Sir, the Lowther observed the change in the length of that repeating pattern, and he had also developed a table. Sir, he has developed a table that resembles the modern periodic table. But his work was not published before Dmitry Mendeleev died.
Okay, okay. Can you draw?
Sir,
It,
drawing.
okay.
Sir, modern periodic table looks something like this. Sir, this is one part, this is other. And underside we are having the lanthanides and actinides.
Okay. So Lowther-Meyer, what something is important. Okay. Lowther-Meyer, for the understanding purpose, all the model are important. Got it. So what he said now, what he said, he took what the volume you take. He took the volume, right? Volume. Atomic volume. Either you say atomic size, you can say atomic size. Also, you can say atomic size or volume. And here it was something, I think mass was there. Okay. So let us see what the point was there. It is having the good point. He said that is similar point in his model. Similar point in his model have similar properties. Got it? Like that. This was there. So what he said, that is on the top, which element was there, he said on the top, that is alkali metal was there. On the top, alkali metal was there. No, if you are talking about the top was the alkali metal. Is there in your NCERT book? NCERT book, it is not there.
No,
Okay. Little bit, you see. When
so
you
that
study,
in that one it is there, sir. That NCERT fingertips or need guide somewhere it is there. This graph, sir, I've seen.
So see, this is the on the top. They are saying lithium, then sodium, then potassium, rubidium, and cesium, because these elements are having the highest size. So the highest size is going to be on the top. Okay. Then what he said, that is, if you are talking about ascending sides, so ascending side can be what they said, that is, it can be the alkaline earth metal. So it can be beryllium, here it can be magnesium, then it can be the calcium, then it can be strontium, and then it can be barium. Then he said, whatever the downside, if you are talking, downside, it can be the halogen. So here is top represent what? That is largest side. Top means largest side, whichever element, largest size element.
Sir, those are the earth metals.
Not earth metal, alkali metal. They are going to be alkali metal. Alkali metal. Okay. Ascending, if you are talking about ascending one, so ascending and descending were there. Descending, descending, and bottom were also there. Okay. So if you talk about the ascending one, so ascending one, alkaline earth metal. Here, alkaline earth metal. Descending metal, if you are talking about, that is he given halogen. Their size are decreasing. Halogens. And if you are talking about the base are there, that is called transition element. But this model was also failed. Transition metal. Can you tell me why this model failed? Any idea? Will you give me any idea? Yes or no? Why this model failed?
Sir, because sir, probably because all the other elements could not maintain this one, sir.
Okay. Because we cannot represent all the element in this way.
And sir,
Okay.
noble gases are also not included in this one.
Noble gas was not included in that one also. Newland one. Newland was what
Yes,
there. After the discovery of the noble gas, immediately it become the ninth element becomes similar in properties. So model it automatically failed.
yes.
Yeah, okay. Now, if you are talking about this model is not that much important. You talk about Mendeleev. Okay. Kindly you tell me Mendeleev periodic law. Mendeleev periodic law. This one you tell me. Then we will study some.
Mendeleev arranged the elements in on the basis of the increasing atomic weights, and he also said that certain elements which come after a few steps, they will have similar properties. He arranged those elements with similar properties under the columns, and the rest was in the form of rows.
Okay. See, the law cannot be a law or the law. Okay. It means they have the implication. We have to memorize in that way only.
Yes.
So see, he said physical and physical and chemical properties of element, elements are periodic function of their. Can you tell me what will come of their atomic mass? Physical and chemical properties of elements are periodic function of their atomic mass. In other words, what you are saying, that was correct. What you are saying, that is
But that is not the correct way to state the laws.
yes. If
Law should be exact.
yes. If elements were arranged, in increasing order of their atomic masses, THEIR, their atomic masses, masses, then after certain interval, properties gets repeated. So both are there. Okay, but what he gave, this one was correct. The point of understanding what, if elements were arranged in increasing order of their atomic masses, you are going to arrange the element in increasing order of atomic masses, then after certain interval, properties gets repeated. Interval. INTERVAL, interval. Interval means after certain time. Interval means time. Properties gets repeated. What do you mean by this?
Sir, can you please wait with this slide for sir 1 minute? I am writing down.
Okay, no problem. Please take your time.
Sir, done.
Okay. See, Sanoy, the Mendeleev model gets failed. Okay.
Yes.
This model actually gets failed. Why the model gets failed? There were some characters are also there, but this model is not having. Because why this model failed? The first point reason was that the main characters of element, main properties of elements are what? Atomic number, not the atomic
Yes.
mass. That is what the first point this it failed. Secondly, there are many things are there. Let us try to write. If I will share the slide now, let me share the slide first. Otherwise, okay. Wait. Just something I want to open. What is coming here? Mendeleev. Okay, got it. Is the screen is visible to you?
Yes, sir.
So here you see the, just want to show you something. Okay. Which one we can see? Let us see this one. What he has done in this all his periodic table, can you see somewhere gap you will find? There are many places he left the gap. Many places.
Yes, sir. Some gaps are visible.
It's getting till now, it is getting open. I don't know why it is. Sorry, it is taking time. Too much time it is taking. Okay. See, Sanoy, here what he did here if you see, you will find that is here he left the gap. Okay, so many places he left the gap. The first
Yes.
gap is below the aluminum. And here you will find that is here is also gap. Okay. Many places he left the gap. What can be the reason if I will ask from you? Firstly, here you see, this is not the actual one. Actual periodic table of the Mendeleev was something different.
Yes,
In
sir.
the,
Like the one is given in NCERT book, that one.
that one we required. That one I am planning to search, but I am not able to find out that one. Not there, no? Not there. What he did na, in his periodic table, let us not waste the time because it is not coming actually. So what he did in his periodic table, na, he divided the element, all the element he divided. How he divided? First of all, see, group he said, group. So group he said that is, earlier he was not placing the 0 group. Then he said that is 0 to 8 group. 0 to 8 group. Total. 0 to how many group? 8 group. So it become 9 group. That is first point was there. It become 9. Can you see? 0 is 1 and then 8 group. Then what he did, 0 group is 1. 0 group is 1. And 1 to 7 group. 1 to 7 group divided into 2. Divided into 2. Divided into 2. 1 to 7 group divided into 2 group. Into 2 subgroup. Subgroup. You divide the 2 subgroup. So this becomes the 14 one, right? And now 8th group. If you talk about 8th group, how many one it is divided 8th group? Can you tell me any idea? 8th group. 8th group divided into divided into 3. Divided into 3. Third. Divided into 3. So total here, if you talk about the group and subgroup, you will find that it is going to be how much? 18. Yes, yeah, no. This is used in modern periodic table. Used in modern periodic table. Modern periodic table. What the Mendeleev said, that is the 0, firstly 1 to 7 he placed, 1 to 8. 1 to 8. Then noble gas discovered. Meanwhile, noble gas get discovered. So he given the noble gas, position for noble gas. And then these groups are subdivided, A and B. This all the group, every group is having A and B, right? Period also he divided, period also he divided. So total period he gave supposed to be 11th period. Nowadays period are there are total period we are having 7 period only. So these all the reason become the failure of this one. There is no need to study detail because Mendeleev periodic table not in use. So only few things are failure is important. Why this model is failed? That I want to know. You tell me why this model failed. There are many reasons are there, but you tell me what the reason.
Sir, that
Huh.
Sir, Henry Moseley showed that the atomic number was more important than atomic mass in case of an atom.
Okay. So main properties of element, elements are atomic number, That is one you told, atomic number, not atomic mass. Okay, not atomic mass. What
Yes.
about other? What about other?
Sir, that other one.
Okay, no problem, sir.
Sir, I do
No,
not have it.
okay. No separate place for isotopes. No separate place for isotopes. Even though they have different mass. They have different mass. Now if you see, that is he was placing the element on the basis of increasing order of their mass. Here the isotope you can find, that is hydrogen is having 3 isotopes. So according to law, if you are going according to law, 3 place must be given. 3 place must be given. Yes or no? According
Yes,
to law means increasing order of mass. So he should give the 3 places. But how many places he gave? But he kept 1 place. But he gave 1 place. 1 place. So it is the direct violation of the law. Yes or no?
Yes, sir.
So why he gave 1 place, but he gave 1 place does not explain. So if you are giving, explain. If you are giving any law, then you must explain that why you are
Yes.
why you are keeping this. So he could not explain that why the hydrogen were given, all the 3 isotopes were given. So it failed. If you are, can I erase now?
Yes, sir.
Now for isobar, if you talk about isobars, so isobar, if you are talking about potassium 40, argon 40, calcium 40, I know these are potassium isotope, one isotope is 40. They are all have same mass. So according to law, what should be given? According to law, all should get 1 place. Yes or no? All
Yes, sir.
should get 1 place. But what happened? If all are getting 1 place, if all are getting 1 place, then okay. But he gave 3 place. He gave 3 different place. Why? How can you give 3 different place? According to the law, it is violation of the law. Yes or no?
Yes, sir.
It is not the increasing order of mass. It is the same mass. So he should keep the same place, but he kept 3 different places. So also failed. Okay. One more advantage. What is the advantage, Sanoy? What is the advantage of this model? ADVAN, advantage of this model. This model was having some advantage also. If you can explain.
The advantage, like it organized the elements into groups and periods based on certain properties.
Yes, that is correct. The first advantage is what there. He left vacant place. Okay. It left
They
vacant place.
predicted the elements that can be discovered later.
Which was useful, useful in discovery of new element. Can you tell me which element were discovered later? He named.
Same eka aluminum, eka silicon, etc. So that eka aluminum is gallium actually.
Eka aluminum is gallium, actually gallium. What is there? Eka silicon. Which one? This one. Eka silicon.
Yes, sir.
Germanium. This is germanium. Okay. So these element were discovered, but the place was there. Properties was properly discovered. Group properties were discovered. So when these element discovered, they were placed there. So this was very advantage for the discovery of the new element. So this is what the points related to. Now let us go the modern periodic table. Okay, modern periodic table. This was given by Henry Moseley only. Okay. And what happened to this one? Firstly, he was studying the spectroscopic nature of the spectroscopic properties. He was passing the wave to the different elements. So what different elements or atoms? So what he found, he found one thing that they are getting the what to say is pattern. What the pattern they was getting here, the correct pattern was getting. See that is, I am trying to explain you. Okay, suppose this is the gas is filled here. Okay, here suppose any gas is there. In this one, gas is filled. Okay. So in this condition, what he was finding when he was passing the light, okay, so he find that is there is the a sequence was coming. Sequence was coming. Okay. The radiation was coming in the sequence, and that sequence was based on what? That is atomic number. When he took the properties by different element, okay, different. If you are taking atomic number,
This
means
is the gas tube, and sir, light was passed inside this one.
So see, in case of atomic number, so similar pattern, a pattern came. He observed the pattern came. But when he was teaching with the mass, when he took the different mass of the gas in the same one, okay, different mass was there. In case was suppose different mass was there, right? Different mass element. So what he was finding now, when he was passing, he was not finding the any proper layer. He did not find. When you are making the graph, do not find the pattern. Do not find the pattern. Find the pattern. So what he said, according to this one, he said that is mass cannot be the idea. Mass cannot be the idea. He said that is atomic number can be the idea, because when when he was passing the radiation, he find that is when he was find a clear pattern he was finding in case of atomic number. In case of mass, there is no pattern. There is no pattern was coming. So he thought that is mass cannot be the appropriate way to describe the properties of element. So like that he given the up now. So what